All right, so I'm going to try to go through this as quickly as we can. So this first one, we're given the line y equals 4 as our revolution axis. So I'm going to kind of write that in, y equals 4. If I'm given a y equals, I know that generally my two lines should also be y equals. So I have a y equals and a y equals. Those are my two lines. They give me also the y-axis, which is kind of like x equals 0, right? So that's an endpoint. The x equals 0 is an endpoint. The other endpoint is going to be where they cross. Now, on multiple choice, you don't have to really write anything. But if it was free response, make sure you're writing 2 plus sine of x equals e to the x minus 3. You can either solve this on the graph with the intersection button or using the solve button. I did it with the solve button. And so, on my solve button, I typed that in. Solve 2 plus sine x equals e to the x minus 3 comma x. I got 3.500. Do be careful. Sometimes with sine and cosine, you'll end up with that weird like n thing. If you get that, you have to do like afterwards at the interval from 0 to say like 4, since that's what they gave us. But we didn't have to do that because these only crossed one time. So anyways, we got x equals 3.5. Now you do want to be careful about writing this. I tell you to always go to 4 decimals. So this would be 3.5001 or 002. But when you type these into your calculator, sometimes it's better to even go to all of the decimals when you stay in your calculator. It just helps you stay accurate. So anyways, now we know it's a volume question. So our formula is volume equals pi integral from a to b of big R squared minus little r squared dx. Right, so our big R is going to be from the line to what's further away, and our little r is from the line to what's closer. So our big R, the top of big R is 4, minus the bottom of big R is this e to the x minus 3. You could graph that, or you could realize this is trigonometric, so that's the sine one. Then for little r, we're going to have the top is 4 minus parentheses 2 plus sine x. You can either leave it like that, or you can do 4 minus 2 is 2. Make sure you distribute minus sine x, okay? So if you're worried about like you might forget the minus, then I would just leave it like that. So you get volume equals pi integral from 0 to that 3.5002 of 4 minus e to the x minus 3 squared minus, now you can either put 2 minus sine x like I did, or you can do 4 minus 2 plus sine x. Just make sure you have like the double parentheses there, squared dx. When you type that into your calculator, you'll get choice A. All right, so I'll show you my calculator very quickly. Right, this is kind of how I typed it in. So I did minus 2 minus sine x, we got 115. Next up, we have the graph of a piecewise function. This is review from last chapter. So whenever we see this right here, we want to kind of immediately write in that g prime of x will equal to f of x. Right, when you take the derivative. And then g double prime of x will equal f prime of x. So if we're talking about anything with g increasing or decreasing, that's going to be the y value of f. If we're talking about anything with concavity for g, that's going to be the slope of f. So it says, which of these values is the greatest? And we asked for g of negative 3, g of negative 2, g of 0, g of 1, and g of 2. So actually everything I wrote didn't matter for this question, but it's good practice, okay? So when we're talking about the g values, we're actually talking about the integrals. So we're talking about the integrals from negative 2 to x of f of t dt. So that's the area under the curve. Right, so when we're talking about just g, it's the area under the curve. So we're starting at negative 2, though. Be careful that we're starting at negative 2. So when we go to negative 3, this is actually backwards. So this is actually a negative area. So this is a negative area. Okay, g of negative 2 would be basically itself. So like starting at negative 2 and ending at negative 2, this is going to be a 0 area. G of 0 is going to be starting at negative 2 and going out to 0. That's going to be this area under the curve. That's a positive area. Then g of 1 is going to be starting at negative 2 and going out to 1. So that's that area in red plus a new area. So I'm going to put positive, positive. I know that's kind of a little bit hard to read. Let's see if we can darken that up a little bit. right? So I'm just putting like two positives just to remind myself it's basically all of that area before, but even more, so it's bigger, right? And then finally we'll have g of 2, which is going from negative 2 to positive 2. So it's all of this positive area, but then we subtract some. So I'm not sure what's bigger, if the 0 one is bigger or if the 2 one is bigger, but I know that's the biggest one, right? That was the biggest one that was positive, right? Because g of 2 is going to have to be smaller than g of 1, right? It's that positive area, but then we subtract something. All right, next we have the base of a solid is a region in the first quadrant bounded by the x-axis, right, which is y equals 0. The y-axis, which is x equals 0. We want to try to write those in. And the graph of the line x plus 2y equals 8. If the cross sections of the solid are perpendicular to the x-axis, that means we're doing dx. Are semicircles, what is the volume of this solid? So basically this is kind of like our delta h. So our delta h is the top of that line. Now we need to isolate it for y. So we have x plus 2y equals 8. That'll give us 2y equals negative x plus 8. That gives us y equals negative 1/2 x plus 4. All right, so the top line is negative 1/2 x plus 4. The bottom line is technically minus 0, right? Y equals 0. So you just have negative 1/2 x plus 4. So this, though, when they're semicircles, that delta h is the diameter. So the diameter is negative 1/2 x plus 4. That means the radius is negative 1/2 x plus 4 all over 2. So the volume is going to be the integral. Now, we start off at 0, and we're going until 8. So the integral from 0 to 8, right, are x values. And the area of a semicircle is pi r squared over 2. Right, or 1/2 pi r squared. So I'll kind of write it that way. So 1/2 pi r squared, that's the area of a semicircle. So instead of putting the r there, we're going to put in negative 1/2 x plus 4 over 2 squared dx. Don't overcomplicate this. Just write it like that in your calculator. It's totally fine. It looks nasty, but you'll end up getting it right. So in our calculator, like I said, I typed it in that exact same way. I had to hit Control Enter to get the decimal, and we got 16.755, which was choice C. All right, next up, we're going to have the region bounded by the graph of y equals 2x minus x squared. The x-axis, which I like to write as y equals 0, is the base of a solid. Each section perpendicular to the x-axis is an equilateral triangle. So the area of an equilateral triangle is kind of that weird one, right? The square root of 3 over 4 times side squared. So if we don't actually have to graph this, but if you did graph this, you get some kind of a parabola. But basically, what we kind of know is that the delta h is the top minus the bottom, which is the 2x minus x squared minus the y equals 0. So if you want to go ahead and graph that, you can. It's going to be some kind of an upside down parabola, right? And then, the delta h is like that. So really what we need to do is we need to figure out our intersection points, though, right? We have y equals 0, and we have that. So we need to figure out, set 2x minus x squared equal to 0. This actually could have been a non-calculator question. It's not, but it could have been, right? Because you could just factor out an x, and it's not too hard to solve. Or, I'm going to kind of do this in my head, but you can definitely use your calculator to solve for that. And so we get x is equal to 0 and 2. So now we're going to do our volume is equal to the integral from 0 to 2 of square root of 3 over 4 times 2x minus x squared dx. Right, so this was the side squared. Again, I skipped a lot of steps on the calculator, right? You could have graphed it on the calculator. It looks like if it's crossing at 0 and 2, it's going to be more like that. And then do the delta h as the top minus bottom. We could have set these equal to each other on the calculator, but we definitely need the calculator to type in our integral. So I'm going to do that really quickly. And so make sure when you type these into the calculator that you don't mess anything up. You don't forget the squared. Always double check it. I've seen a lot of students get these questions wrong because when they typed it in, they forgot the squared right here. I've also seen students who just type it in and it doesn't pop out the same, and they just pick a wrong answer because none of their answers showed up. Really double check your work if you're getting something that doesn't show up. But I got 0.4618, which matches up with choice D, which is our correct answer. Another thing to watch out for, I've seen students who add pi here. Pi does not go in anything with cross sections. You only put pi in if it's a circle, right? Otherwise, it's just the area of that shape. So this one, the area of a triangle doesn't have pi in it. All right, next we have the graph of a function is shown, and we have the horizontal tangent line at x equals 4 and 8. So they're telling us that we have horizontal tangent lines at 4 and at 8. And then we're given if g of x is equal to x squared minus 2x of f of t dt, what is g prime of 3? So before we can do g prime of 3, we have to do g prime of x. The derivative of x squared is 2x. And then for the derivative of this part, you got to be careful about the minus sign and the fact that we have to do chain rule. So it's going to be minus, the derivative of 2x is 2 times f of 2t. Remember, anytime it's anything other than x, we have to do that chain rule. So this becomes g prime of x equals 2x minus 2 f of, it wasn't 2t, it was 2x, right? We plugged in 2x, f of 2x. So now for g prime of 3, 2 times 3 is 6, minus 2 f of 2 times 3 is 6. So we want f of 6. So the value at f of 6 is negative 2. So that's 6 minus 2 times negative 2. That's 6 plus 4 is 10. So choice B. So even though they told us this whole horizontal tangent line stuff, in this case, that was just extra information. We didn't need it. Which of the following is a solution to the differential equation? So this is review from last chapter, right? We're adding this to this test. So this is where we're going to multiply both sides by dx. If there was any y values, we would divide them. There aren't here. So you get dy equals 2 sine of x dx. This one is a pretty simple one, all things considered. The integral of dy is y. The integral of sine is negative cosine. So it's going to become negative 2 cosine of x plus c. And now we're going to plug in our initial condition, 1 for the y and pi for the x. Cosine of pi is over here, is negative 1, right? So negative 2 times negative 1 becomes positive 2. Subtract the 2 to both sides, we get negative 1 equals c. Plug that back in up there. And we'll end up with negative 2 cosine of x minus 1, choice E. Then this last one, the graph of the function shown above has horizontal tangents at 2 and at 5. Let g of x equal the integral from 0 to x. For what values does this graph have a point of inflection? So g having a point of inflection, that's g double prime changing signs. So we're going to kind of write up here g prime of x equals f of t, and g double prime of x equals f prime of x. So we want g double prime to change signs. But what we need to do is we need to refer to the graph of f. So what is g double prime? It's f prime. So we want to know when does f prime change signs. Right, f prime is if our graph is increasing and decreasing. So it's increasing, then decreasing. So it changed from f prime being positive to f prime being negative. Then right here it's decreasing, and now it changed back to f prime being positive, which was increasing. So it's going to change signs at 2 and at 5. If it asked for where does the graph have like critical points, we would set f of t equal to 0. That would be at 4, right? Not 0 and 6 because they're endpoints, but 4. All right, moving on. This one's kind of similar. This is actually very similar to the question we had on our last test, I think. So we have a graph like this, and it says find the values of g of 3, g prime of 3, and g double prime of 3 if they exist. So the very first thing, and you get points for this, is we want to set g prime of x equal to f of t. We want to set g double prime of x equal to f prime of t. Even if we don't do anything else, we're guaranteed to probably get a point there. So for g of 3, that's going to be the integral from 0 to 3 of f of t dt. So that's the area under the curve. So starting at 0, ending up at 3. This is a positive area and a negative area. So this is going to be, that's a quarter circle, so 1/4. Pi, the radius there is 2 squared. And then minus, because the triangle is below the axis, 1/2. The base is 1 from 2 to 3, and the height is 1. Okay. Don't do negative 1. We already did that by putting the minus there.
2 squared is 4, so we get pi minus 1/2. Just box that. That's our answer. So g of 3 is pi minus 1/2. Next, I'm going to do g prime of 3. So g prime of 3 will be f of 3, which is just going to be the y value at 3, which is -1. And then g double prime of 3 equals f prime of 3, which is going to be undefined. Okay. So we need to give a reason if we say undefined, right? Why is it undefined? Well, the slope at 3 makes a corner. So undefined because we'll say f prime of 3 is not differentiable because the graph, I'm going to just write down here, of f has a corner at x equals 3. Okay, we do want to really fully explain that, right? We want to make sure that we fully explain that answer, that we're saying it's not differentiable, and then why is it not differentiable? Because the graph has a corner at x equals 3. We want to be specific there. Okay. Find the x-coordinate of each point of inflection on the graph of g. So remember, we have a point of inflection when g double prime of x, which in this case is equal to f prime of x, changes signs. Now, where do we look for those? We look for them when g double prime of x, which would be f prime of x, is either 0 or undefined. Those are our possible points of inflection. So when basically, g double prime of x, which is equal to f prime of x, is either 0 or undefined. Well, f prime of x is 0 whenever we have a horizontal tangent, and undefined whenever we have a kink or a corner. So our possible inflection points, right, those possible inflection points would be x equals 0, 2, and 3, right? So we can even write that. We'd say possible inflection points are x equals 0, 2, and 3, right? If you wanted to, you could even write because g double prime of x equals f prime of x is 0 or undefined, right? But which one is not? 2 was not. And why? Because this graph is increasing, then decreasing, then it continues to decrease, and then it increases. So it didn't change signs at 2, right? It kept decreasing. So, g double prime is positive, negative, kept being negative, and then positive. So the easiest explanation for this is to say, g has inflection points at x equals 0 and 3 because g double prime of x equals f prime of x changes signs at x equals 0 and x equals 3. It's like the simplest explanation. C is probably the trickiest one, find the absolute minimum, but you can always guarantee yourself a point by just saying g prime of x. Now in this case it's equal to f of x is equal to 0, and so then find when f of x is 0. Well, f of x equals 0, that would be our zeros of the graph, so that's at 4 and at 2. We're not going to include -2 because it's an endpoint. We're already going to have it. So x equals 2 and x equals 4 are our answers there. So we're going to put this happens at x equals 2 and 4. Now we're going to make our table, and like I said, this is usually 1 point, maybe even 2 points. Okay. So if you're lucky, you might even get 2 points from that. So x, and we're going to put g of x because we're finding the minimum of g. So we're going to put our endpoints, -2 and 5. Then our critical points were 2 and 4. So the formula that we were given was g of x equals the integral from 0 to x of f of t dt. So we're going to take this formula and do it for each of those. We're going to do g of -2 will equal the integral from 0 to -2 of f of t dt. So 0 to -2 will be going backwards. So that's a negative area because we're going backwards. Even though it's above, it's a negative area. Now we already kind of did this work, right? We did this quarter circle, we got pi. So we don't have to reinvent the wheel. We already know it's pi, but since we're going backwards, it's negative pi.
You could show your work and say like negative 1/4 times pi times 2 squared, right? But you're going to cancel out and you're going to get negative pi. Same thing for g of 2. Now g of 2 is the other side of the circle, quarter circle, and we've already done this work and we've already got in pi. So we don't really have to show all of our work. We can just put in pi, right? You don't really need to show all of your work as long as you've written this down. They're going to be okay with you doing some of those calculations in your head. Now for g of 4, we've already done g of 3, right? So we've already done g of 3, so we can basically do g of 3 and then add on from 3 to 4. Or we can do g of 2 and add on from 2 to 4. I'll kind of do that. So I know that this section here, starting at 0, this section is pi. So now I need to subtract that triangle. That has a base of 2 and a height of 1. So I'm going to just say this would be pi minus 1/2. The base was 2 and the height was 1. So that gives us pi minus 1. And then finally we'll have g of 5. Now for g of 5, we can basically start off with that pi minus 1, right? Because that's the area up until here. And then we can just add on whatever's new. So that's a new triangle, which is above the axis. So it's going to be plus 1/2, base is 1, height is 1. So we're going to do pi minus 1 plus 1/2 times 1 times 1. That's going to end up with pi minus 1/2. So they asked us for the absolute minimum value. And this is a little bit hard, but kind of remember pi is 3.1. So 3.1 minus 1 is 2.1. And 3.1 minus 1/2 is going to be like 2.6. So the smallest value is at that negative pi. So we're going to say the minimum is at, I like to kind of do it this way. G of negative 2 equals negative pi. So I just put g of, the x equals whatever the value is. You don't need to explain it because your table and your work explains it. Right, moving on to the non-calculator section. So using the substitution u equals square root of x, this again is review. So what we want to make sure we kind of know is, okay, u is square root of x, then what is du? Okay, so our du, du is going to be 1 over 2 square root of x, dx. And so what we need to kind of do here, right, we have 1 to 4 of e to the square root of x over square root of x dx. This one's a little tricky because you have this denominator, but we see square root of x is in the denominator. That's good. That's where we want it. And dx is here. So what's missing from the du is the 2, but it's a 2 on the bottom. So it's kind of like a 1/2. So we're going to multiply by 1/2. That means outside we're going to multiply by 2 over 1, the reciprocal. So now this whole part, the 2 on the bottom, square root of x dx becomes du. And then up here in our numerator, the square root of x in the e part, that's going to become our u. So we also will need to change our endpoints. So we need to change our endpoints by plugging them in to the square root of x. And so this becomes 2. Then the square root of 1 is 1. The square root of 4 is 2 of e to the u du. So that would match up with choice C. All right, so be careful about that. The hard part on this one is that 2 over 1 business, right? Because we're multiplying by 2 in the denominator, so that's a 1/2. So that's kind of the tricky part about that. And make sure you change your endpoints. You can always cancel out the wrong endpoint ones. So on this one, it's really easy to just cancel out B, A, and E because those didn't change our endpoints correctly, right? Just plug your endpoints in there. Now we're down to a 50-50 shot. And from there, honestly, a good test-taking strategy would be if you saw 2, 2, 2 on the outside, it's probably C. You'd probably have guessed that without doing any work. But it's good to still kind of do it because graders can be tricky. They might do that on purpose and put distractors for students who are cheating and doing it that way. So be careful. But if you totally get stuck, that's kind of a method to look at. Okay, here's another u sub 1. So our u here is going to be negative 4x, and our du will be negative 4 dx. So I'm going to multiply times negative 4 inside times negative 1/4 outside. I like to plug in my endpoints, so I'm going to. You don't have to. When I plug in 0 times negative 4 is 0, 1 times negative 4 is negative 4, and then this will be of e to the u du. The integral of e to the u is e to the u, it's itself, from 0 to 4. This gives us negative 1/4 e to the 4 minus negative 1/4 e to the 0. When we look at the answer keys, none of those are there, and that's because e to the 0th is 1, right? Anything to the 0th power is 1. So this simplifies to negative 1/4 e to the 4th plus 1/4. Again, none of those are there, but one of them kind of is. It's just that they took this and put it in front. So that's choice D. So, be careful about whether they combine like terms or if they flip, the order. That's totally the same answer, right? That's like the commutative property from like 8th grade math. All right, so region R is the region in the first quadrant, bound by the graphs of f of x equals square root of x, g of x equals 6 minus x, and the x-axis, find the area of R. There are two ways to do this one. You can either do a right minus left integral, or you can split down the middle, and I kind of like to split down the middle. I find it easier, but I'll show both ways really quickly. So if we split it down the middle, this is the area from 0 to 4 of f of x, and this is the area from 4 to 6 of g of x. So we have the 0 to 4. The f of x graph is square root of x, and then plus from 4 to 6, that's the right side, of g of x. Now for the g of x graph, right, that's y equals 6 minus x, so 6 minus x dx. And so I can change this to 0 to 4 of x to the 1/2 dx, plus the integral from 4 to 6 of 6 minus x dx. So this becomes x to the 3/2 over 3/2 becomes times 2/3 from 0 to 4, plus, okay, this is going to be, I'm going to put this guy in parentheses, 6x minus x squared over 2 from 4 to 6. I like to put the second one in parentheses just in case there's a negative sign or anything like that. So this becomes 2/3. Now, 4 to the 3/2 power. Okay? When I do 4 to the 3/2 power, that's like 4 cubed and then the square root. You can do either first. You can do square root first or you can cube it first. I like to square root it first. So what's the square root of 4 is 2. 2 cubed is 8. So it's going to be times 8. Then minus anything times 0 is just 0. So that one's easy. Then plus, now 6 times 6 is 36. Minus 6 squared is 36 over 2 is 18. Minus, then 6 times 4 is 24. Minus 4 squared is 16 over 2 is 8. So this is going to be 2/3 times 8 is 16/3. Plus, then in parentheses, this is 18. Minus 24 minus 8 is 16. So that's 16/3 plus 2. Okay, we'll lollipop that 2 over 1, right, to get like terms. Times 3 is 6 over 3, which is 22/3. So choice B. Okay. So it's a lot of work, but we were able to get it. Now, I would not really recommend this, but just kind of to show it, we could as well do a right minus left. So if we had y equals square root of x, though, we need to solve for the x. So we get x equals y squared. And then here we have y equals 6 minus x. So subtract by 6, divide by the negative, and we get x equals basically 6 minus y, or negative y plus 6. So now we could do a right minus left, kind of doing it this way, right? And our endpoints would be the y values, 0 and 2. So we could say that the area of this is the integral from 0 to 2 of, now the right side is the g one. So 6 minus y, that's the right side, minus the left side is y squared dy. And the integral actually ends up being a little bit easier, I think. So integral from 0 to 2 of 6 minus y squared dy. So we get 6y minus y squared over 2 minus y cubed over 3 from 0 to 2. And then that will give us 6 times 2 is 12, minus 2 squared is 4 over 2 is 2, minus 8/3, and minus 0. This is 10 minus 8/3, which is 30 over 3, minus 8 over 3 is 22 over 3. So we actually get the same answer, and it actually ends up being a lot less work when we do it right minus left, but I know a lot of us just get kind of scared by the setup of that. So I would still probably recommend doing it in blue. I think the way in blue is easier to visualize, but I do want to show, that we could do that either way. All right, next one. This is going to be the FTC Rule 2 with chain rule. So we have that d dx, but we have a 2x here. So we need to make sure that when we plug that in, we're going to get 2, right? This is going to be g prime of x equals, or f prime of x, equals 2, and then times the square root of, now when we plug in 2x here, we need to make sure that we do 2x squared, all of it, minus 2x. So we got to be careful, because what's going to happen is the squared is going to go to the 2 and the x and become 4x squared minus 2x. So this is f prime of x. We didn't want f prime of x, but we have to do that first before we can do f prime of 2. It's going to be 2 square root of 2 squared is 4. 4 times 4 is 16. Minus 4, that's 2 square root of 12, which is choice E. All right, next we have a slope field one. I told you guys I like to plug in one from each quadrant. So first I'm going to plug in something from 1, 1. Right, so x over y is going to be positive over positive. And at 1, 1, we want a positive, right? Like this is a positive value. So we want a positive. So this one is in play. 1 squared over 1 squared is positive over positive, still in play. 1 cubed is positive over 1 is positive, so still in play. 1 squared is positive over positive, still in play. And 1 cubed is positive over positive, still in play. So this quadrant didn't help us out a lot. That's okay. We'll move on to the next one. So at the second quadrant, x would be -1, y would be +1, right? I'm kind of plugging in this value. And we want to get a negative value. Okay, so we want a negative value. So x is -1 over +1. That is negative. Okay. -1 squared turns positive over +1 squared is positive. This is now canceled out because that would have given a positive value. We wanted negative. -1 cubed is negative over over y is +1. So this is a negative value still in play. -1 squared becomes positive over +1. We're going to cancel out choice E. And -1 cubed is negative over +1 squared is positive. This is still in play. Okay, let's move on now down to the third quadrant at -1, -1. It looks like that's a negative value. So when they're both negative, we get a negative value here. So -1 over -1 is positive. And we wanted a negative. So we're going to cross out A. -1 cubed is negative over -1. Is positive. Again, we wanted a positive value. And -1 cubed, we wanted a negative value, and this was positive. -1 cubed is -1 over -1 squared is +1, which is a negative value. So our answer would be choice C. So it's kind of a lot of work, but if you do it this way, you're always going to get the right answer. It just might take you a little bit of time. All right, next we have the graph of a differentiable function. We have the same process where we're going to do the FTC. And which of the following statements is true? So we're going to do h prime of x equals, we'll do the whole d dx business, f of x, and then h double prime of x equals f prime of x. So what we know is basically based on the graph of f, that h of x is the area under the curve. Right? So h of x is the area. H prime of x is the y value. And then h double prime of x is the slope. And generally, I've told you guys what happens on these. Not always, but generally, one is negative. Then one is 0 and one is positive. That's the goal. Sometimes, 2 will be negative, but one will be, clearly more negative. But most of the time this happens. So we'll see. Hopefully we get something like that. So anyways, in this case, we are going to have, looking at 6. So at 6, we can see, if we did the area from 0 to 6, that area is negative, right? So that h of 6 is going to be a negative value. Then h prime of 6, that was our y value. H prime of 6, the y value is 0. Okay. And then h double prime of 6, that's going to be our slope. This graph is increasing right now, so that's going to be positive. So it's going to go in that order. H of 6 less than H prime of 6 less than H double prime of 6. It's just a coincidence that it went like H prime, H double prime. That doesn't always happen. That actually pretty much rarely happens. But in this case, that was true because we're going the negative 0 positive. All right, 14. This one is tricky. This one, if it's on your test, will be as extra credit. This is that super hard rule about the u sub. So basically in this case, right, our u is going to be our denominator, the x squared minus 4 term. And du, oh no, this isn't the, never mind, this isn't that case. This is just a normal u sub. So du is 2x dx, so times 2 times 1/2. And we get 1/2 integral. The 2x dx becomes du, I'm going to put at the end, and then the 1 over x squared minus 4 becomes 1 over u. This becomes 1/2 ln of u plus c. We plug this back in for the u, and we get 1/2 ln of x squared minus 4 plus c, choice c. Right. So I might put on the exam one of those really hard u sub ones as extra credit. If you want to review that, go back to the last test video I made, and there are a couple of those in there. All right, for the free response here, we're given a slope field, and we have to graph this. I'm not really going to go over, how to do it because there's so many different ways. It's basically just plugging in. You can make a table, you can do it in your head, whatever you want to do, look for patterns. So I like to kind of start off at 1, 1. Now, when I notice though that 1 minus 1 over 1 squared, that's 0 over 1. So this is going to be 0. So what that actually tells me is anything with y equals 1 is 0 except, right, if I get 0 over 0. We want to always watch out for 0 over 0. So this whole x squared is blank. The reason it's blank is it's all undefined. If it wasn't, you would make vertical lines, but it's undefined then. Okay, now let's plug in, like, say, 1, 2. So x is 1, y is 2. 2 minus 1 over 1 is 1. So we're going to make a slope of 1. I'm kind of trying to connect it, up 1 over 1. So connect it right there. All right, then I'll do 2 and 2. 2 minus 1 over 2 squared is 4. That's 1/4. So down 1 over 1, 2, 3, 4. We're kind of imagining it was going to cross there. So a much more shallow line. Then I'll do maybe negative 1 and 2. So 2 minus 1 over negative 1 squared. That also gives me 1. So kind of up 1 over 1, trying to make it like as even with that guy's possible. If it's not fully even, that's fine, but just try to make them the same. And now let's do the zeros. I'm going to start off with 1, 0. So 0 for the y, 1 for the x. That's negative 1 over 1 is negative 1. So down 1 over 1, or backwards. So we're kind of connecting it that way. And you should be able to notice this one's going to be the same, right? Negative 1 over negative 1 squared is also negative 1. So trying to make these parallel or the same. And finally, for this last one, we're going to have 0 minus 1 is negative 1 over 2 squared will be negative 1/4. So kind of the opposite of this one. So up 1 over 4 is going to be kind of connecting there. So a very, very shallow line. All right, so now find the particular solution. That's when we solve it, when we have the initial condition f of 2 equals 0. So we had dy dx equals y minus 1 over x squared. And this one's a little bit tricky because we want to have the x on the right side and the y on the left side. So what I do on these is I kind of just extend my line out. And I say, okay, I need to divide by y minus 1, put that in parentheses. And then I need to multiply by dx. That's going to go to the numerator. So that cancels, and we end up with dy over y minus 1 equals dx over x squared. And that's how we want to write it. You can rewrite it as 1 over y minus 1 dy equals 1 over x squared dx if you want to move those to the outside, but make sure it's 1 over, right? Those are fractions, they're in the denominators. So now we're going to take the integral of both sides. Hopefully you've gotten good enough of these that you can do this without u sub and just make it ln of y minus 1. But if you haven't, go ahead, feel free to do u equals y minus 1, u equals 1 dy, and do u sub. You'll get here eventually. Here, this is the integral of x to the negative second. When we add 1, that becomes x to the negative first over negative 1 plus c. I'm going to rewrite this as ln of y minus 1 equals negative 1 over x plus c. And now we're going to do e to the power of both sides. Those cancel. We take our c, we bring it to the front, which allows us to drop the absolute value. Kind of right up here. So we get y minus 1 equals c e to the negative 1 over x. Add 1 to both sides. Y equals c e to the negative 1 over x plus 1. Now we'll plug in our initial, 0 for the y and 2 for the x. Kind of a weird one. And then we get, solving for c, negative 1 equals c e to the negative 1 half. Divide by e to the negative 1 half, that's negative 1 over e to the negative 1 half equals c. You can box this and make your answer y equals negative 1 over e to the negative 1 half times e to the negative 1 over x plus 1, and you'll get totally full credit. You don't have to like think about simplifying this or doing anything weird. If you do look at an answer key for a question like this, though, what they'll probably do is they'll notice that this is a negative exponent. And so they'll say, oh, c is that negative 1, but they'll bring the e to the negative 1 half up and make it e to the half. So when they plug it in, they'll get e to the 1 half times e to the negative 1 over x plus 1. And they might box this as the answer. Or they might even go a step further and notice if you have e to the power and e to the power, you can add those. And so you can make this 1 half minus 1 over x, and then plus 1. So all of those are valid answers, all three of them. I would probably just stick with this one, but I just wanted to show you guys, what you could do to simplify. All right, next, describe all the points where the slope of the tangent line would be positive. So we want to figure out, where would the slope of the tangent line be positive? Well, we had y minus 1 over x squared. We want to kind of think about the top and the bottom. When is the top going to be positive? When is the bottom going to be positive? The bottom's always positive. So when would the top be positive? Well, when y minus 1 is greater than 0. So when y is greater than 0. Now you want to be careful because you also need and x cannot be 0. So that would be all of the points. For these ones, I am not going to go through them. I think they're just kind of extra practice for you. You have the answer keys. So I'm not going to go through these free responses or just make the video too long, but you should have the answers for those up here somewhere. And if you don't have any of the answers or if you get stuck on any of those and you want to know them, send me an email. We can always review them. If it's like super, super urgent, remind me before the test tomorrow and we can review 1 or 2 of them before the test. But I don't think that those should be too hard. Okay, good luck studying and I will see everyone tomorrow.